Imagine a world where the sky is a permanent, impenetrable orange. A world where the air is so thick it would feel like walking through a heavy fog, and the pressure on your skin is nearly 60% higher than at the bottom of Earth's deepest oceans of air. This is Titan, Saturn's largest moon, a place that has remained one of the greatest enigmas of the solar system since its hazy atmosphere was first glimpsed through telescopes in the 1940s. For decades, scientists could only wonder what lay beneath that toxic shroud. Was it a global ocean of chemicals or a barren, icy wasteland? Titan is not just another moon. It is a world that defies the standard rules of the outer solar system. While most moons are airless cinders of rock and ice, Titan is wrapped in a dense shield of nitrogen and methane. In fact, it is the only moon in our solar system with a substantial atmosphere. This gaseous envelope is so thick that it completely hid the moon's surface from the eyes of the Voyager 1 spacecraft as it flew by in 1980. It wasn't until the arrival of the Cassini-Huygens mission in 2004 that we finally began to peel back the layers of this orange mystery and see the face of this terrifying world for the first time. What we found was a landscape that is both eerily familiar and utterly alien. At a staggering 1.4 billion kilometers from the Sun, Titan is a place of extreme cold, with surface temperatures hovering around -179 degrees Celsius. At these temperatures, water does not flow. It is as hard as granite, forming massive boulders and rugged mountain ranges. Yet, despite the lethal chill, Titan is a world of active geology and weather. It is a place where methane plays the same role that water plays on Earth, acting as a condensable gas that forms clouds, falls as rain, and carves winding river channels into the icy crust. This greenhouse hydrology taken to extremes has created a world that is essentially a giant abiotic organic factory. The sheer abundance of carbon-based molecules on Titan exceeds the Earth's entire inventory of fossil fuels and biosphere by more than an order of magnitude. It is a world where the very rain is made of the same materials we use as fuel, pooling into vast, calm seas of liquid gasoline like hydrocarbons. As we stand on the threshold of this alien shore, we must ask, what kind of secrets are hidden beneath those dark, shimmering waves?
To understand Titan, you must first forget everything you know about weather. On Earth, our world is defined by the water cycle, a delicate balance of evaporation and precipitation that sustains all life. But on Titan, the temperature is so low that water is a rock, and the water cycle is replaced by a chilling alien equivalent, the methane cycle. At -179 degrees Celsius, Titan sits near the triple point of methane, a rare physical state where a substance can exist simultaneously as a solid, a liquid, and a gas. This allows Titan to possess a greenhouse hydrology taken to extremes, creating a world where it doesn't just rain, it rains fuel. The clouds that drift across Titan's orange sky are not made of water vapor, but of methane and ethane. While the overall intensity of this cycle is weak compared to Earth's, averaging only about 1 centimeter of rainfall per year, the atmosphere itself is a prodigious reservoir. It can hold the equivalent of several meters of liquid. When these clouds finally break, they don't produce a gentle drizzle. Instead, they unleash violent, catastrophic monsoons that can carve deep, jagged channels into the icy crust. These storms are so massive that it can take up to 1,000 years for the atmosphere to recharge its moisture after a single event. When the rain falls, it flows through winding riverbeds that resemble those found in the American Southwest, but with a terrifying twist. The water is actually liquid methane and ethane, substances we know on Earth as the primary components of natural gas and gasoline. This liquid pools in vast basins near the poles, creating the only stable bodies of surface liquid found anywhere in the solar system besides Earth. Some of these seas, such as Kraken Mare or Mare, are truly immense, rivaling or exceeding the size of North America's Great Lakes. Standing on the shore of a Titanian sea would be an experience of profound, eerie stillness. Because the atmosphere is so thick and the gravity is only 1/7 that of Earth, waves on these gasoline-like oceans move in slow motion, rising taller but traveling much slower than waves on Earth. These seas are part of a massive organic factory. The sheer volume of hydrocarbons on Titan is staggering. The moon's lakes and dunes contain hundreds of times more organic carbon than all the known oil and gas reserves on Earth. It is a world of incredible wealth, locked in a deep toxic freeze, waiting to reveal what might be swimming in its dark chemical depths.
The mystery of Titan remained largely impenetrable for decades, hidden beneath its thick orange shroud. But on January 14, 2005, humanity finally pierced the veil. The Huygens probe, a small robotic emissary built by the European Space Agency, detached from the Cassini orbiter and began a harrowing 2.5-hour descent toward the unknown surface. As it plunged into the dense atmosphere at 21,000 kilometers per hour, it was met with atmospheric pressure 1.6 times that of Earth. This thick, gaseous armor, the only substantial atmosphere on any moon in our solar system, provided the friction necessary for the probe's heat shield to glow with the intensity of a small star before parachutes deployed to slow the craft to a gentle drift. During the long drift downward, Huygens cameras began to resolve a world that looked eerily like Earth, but warped by a deep chemical freeze. From several kilometers up, it captured images of complex drainage networks, dark, branching channels that wound through rugged, bright highlands. These were not carved by water, but by the relentless flow of liquid methane and ethane, a terrifying realization that the weather on this moon was a chilling reflection of our own. The probe even recorded the sounds of the Titanian wind, a low, haunting whistle that echoed through the orange haze as the craft descended toward its final destination. The landing itself was a moment of profound scientific triumph. Huygens touched down not in a global sea, as some had predicted, but on a flat, moist plain. The surface had the consistency of wet sand, or crème brûlée, composed of water ice grains soaked in liquid hydrocarbons. The first ever photo from the surface revealed a landscape strewn with rounded cobbles. On Earth, such stones are smoothed by the tumbling action of river water. Here, they were boulders of water ice, frozen harder than granite, polished by the flow of liquid fuel. As the probe sat on the alien soil, its sensors detected a surge of methane gas released as the warmth of the craft began to evaporate the liquid beneath it. For 90 minutes, Huygens whispered its findings across 1.2 billion kilometers of space before its batteries finally succumbed to the -179-degree chill. It left behind a legacy of a world that is geologically young and remarkably active, a place where the very landscape is shaped by organic chemistry on a planetary scale. We had finally seen the face of Titan, and it was more alien than we ever dared to imagine.